All right, guys, welcome to Stats 2.2. We're going to be talking about graphs today. All different types of graphs, bar graphs, and circle graphs, and time series graphs more specifically. So a lot of these are types of graphs that you've seen in the past. So nothing is going to be brand new to you. But I want to talk more specifically about kind of how we make these graphs correctly so that they're not misleading, what certain graphs are better at other graphs at doing, so that when you're trying to figure out, hey, what graph do I want for this particular presentation, you can say, well, I want this one because I'm trying to show this or because I have this type of data. So first one, bar graphs, you've seen these types of things quite a bit. You can see them either vertically or horizontally. A few things that we want to keep in mind is we want the spacing between all of these to be the same, and we want to keep the actual scale, so this kind of y-axis in this case, to be the same for every single graph. If you don't do that, things can be misleading. You also want to have the width of each bar being the same. If I were to make one bar a bit wider than the others, visually that takes up more surface area, so you're going to think, hey, that is more than something else. That might actually be less. It's a minor thing, but it does kind of cause some unwanted bias that we're trying to keep out of these graphs. So other things here, this is an example of a bar graph. This is one that I like a lot because it's the births per month, which those people think, hey, if people are born entirely randomly, right? So every day there's the same number of babies born on any given day, right, ish. But really, you see these massive spikes and you see these massive lulls, right? So you're going to see these big old spikes in May, June, and July. So a lot more people have birthdays then. And then August is actually a very low day for a number of birthdays. That doesn't mean you're never going to meet a person who was born in August. It just means that's less likely than someone born in June or December, as we're seeing here. And you can do a quick little fun game here and take a look at, hey, what's 9.5 months earlier to these kind of spikes, and you can see maybe some things might have happened in 9.5 months prior to these dates. That's 40 weeks, which is the gestation period of humans, in case you didn't know. So, for instance, we see this big spike here in June. So if we go back 1, 2, 3, 4, 5, 6, 7, 8, 9.5. We're right in the midst of like kind of the summary type. Another one here is in December we see a spike. Go back 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're kind of in March and early and middle of February, which is where you're going to see Valentine's Day, stuff like that. So you can kind of have a little bit of fun there, but don't think about it too much. Okay, so a different kind of caveat for bar graphs is what are called cluster bar graphs. And you've definitely seen these ones before too. So we're going to see more than one bar kind of touching in these little kind of groups. So for instance, this graph that I have here is different types of vehicle and as they are sold in different regions. So we have Asia, Europe, and the US markets. So we can use this to try and compare how different regions or different groups look on the same set of data. So for instance, we can see, hey, trucks, we sell a lot more of those in the US and almost none of those in Europe. Whereas sports cars in Europe are way more popular there than any other region. So you can kind of use that to compare different categories amongst larger categories. For instance, type of vehicle, and then comparing it to, or comparing it between the markets in which those are being sold. And then I want to talk real quickly about scale breaking. So, for instance, you're going to see here an example of a actual scale break. So they're typically represented with this little zigzag. You want to always do that if you ever break your actual scale to kind of jump up to a portion. So why that is done is, so our numbers here, for instance, are in the like 70s and like 80s. So our lowest number is like maybe 72, and then our highest one gets up to like maybe 82. So there's really a fairly narrow margin of difference there. And if I had this graph zoomed all the way out, going from 0 to 80, you could barely see any difference between, say, 72 and 73, or 72 and 72 and a half, right? So this is effectively a way of kind of zooming in on the parts that are important, right? The thing you want to watch out for here is if you do that, um, and you are kind of misleading in a way, right? So I could have it be, if I put the break at like 0 to 50, so it jumps here at 0 to here at 50, and one thing is 51, which is here, and then the next thing is 52, which is here, right? I'm seeing a massive jump visually, even though it's a very, very minor jump in the actual numbers. So you typically want to give still a good amount of room before you actually start to see those differences. So you wouldn't want to jump all the way here to like 65 and then have your graph start here, because then you're going to see, hey, this one's tiny and this one's huge relatively. So they can be misleading. So you want to be really careful when you use those and be very specific that you're using it not in a way to make things look different. So now I'm going to show you my favorite example of a scale break gone wrong. And that is this graph right here. So this is a graph of the average female height in different countries. So there's a few things wrong with this particular graph. The data is not incorrect. The data is actually fine. The two things that are kind of causing problems here, the first one is the actual scale break, right? We're jumping from 0 feet to 5 feet here, and then 5'1", 5'2", 5'3", 5'4", 5'5". So here, from here to here is a 5-inch difference in height, which is noticeable but not massively drastic, right? And the second problem is they're actually using a picture. So the bar widths are wider for stuff here like in Latvia. The width is actually wider than it is down here in India. And that's just because they're kind of actually scaling up that picture in both the vertical and the horizontal axis, as opposed to just purely a vertical axis. So again, there's another place where you can kind of see those biases kind of seep in. But I just think this is hilarious because this graph makes women in India look like they are incredibly small, like they're up to your knee kind of height, like they're literal smaller than toddlers at times, right? And then women in Latvia seem like they're these massive hulking beasts, right? When really they're just an average of 5'5", which is pretty darn normal, right? So this is a bit silly and kind of hyperbolic, but hopefully it kind of shows, hey, here's where we might have some of those issues. Okay, next type of graph is a pair 2 chart. These are kind of a type of bar graph. Really, it's a bar graph where we kind of order it in a very specific way. We either order it from the greatest down to the least, or from the least up to the greatest. So, for instance, if I have this data here, right? I want you guys to pause the video, create a bar chart with this data, but have it be the largest first, and then second largest, third largest, fourth largest, all the way down. So that is how we're going to create a pair 2 chart. So go ahead, pause it, and try and create that. Okay, so it should look kind of like this, right? So this is reasons why Winifred is late to her first period class every day. So we can see we have last minute studying, and then snoozing the alarm, too big of too long eating breakfast, stuff like that. So why you might want to do this, right? The reason why we'd want to reorder this is if what we care about is what's happening the most. So for instance, Winifred probably cares most about, hey, what things could I change that are going to have the biggest impact on me being late? So she would say, well, the two top ones are last minute studying and snoozing my alarm. So if I can stop those two things, that'll have the biggest effect on why I'm late. Versus if she says, well, if I just focus on trying to pick out what I wear the night prior or something like that, that will have an effect, but not nearly as big of an effect as trying to deal with these larger ones. So again, the big thing here is why you'd want to use a pair-2 chart as opposed to just a normal old bar graph is if you care more about what's the biggest or what's the least, as opposed to just, hey, how do these things compare in general? So for instance, if I jump back to the one here, right, it wouldn't really make sense for me to put sedans in front of SUVs and in front of sports cars and so forth. I mean, I could if I'm trying to say, hey, look, more people buy sedans than the other types of the cars. But if my point is just to kind of say, hey, here's how these compare, there's no reason for me to order it in that pair-2 chart way. Other ways you might want to order it like this one here in chronological order, which makes sense most of the time. So if you're going to make a pair-2, make sure you have a reason for why you're going to set it up as a pair-2, not just because why not. Okay, so circle graphs, you may also hear these called pie graphs or pie charts. All really the exact same name. Our book is going to use the term circle graph, so I'm going to try and use it just so that we are not getting confused, but they're literally these same things, so don't worry about it too much. So we all kind of know how they look, but constructing them is a little bit more complex. So I have some data here. All right, so this is the number of time spent talking on the phone after 5 p.m. This is clearly done with older generations because most of us don't really talk on phones at all anymore. But we can still use the data, right? So less than half an hour, we had 296. Between 1/2 and 1 hour is 83, and more than 1 hour, 121 people. So this is out of 500 people in the, out of 500 people in the U.S. And to figure out, well, what size does my chart need to be? Because most of you have made these on a computer program in the past, but to make it by hand, you first have to figure out how much of the whole that is. So this first one is 296 out of 500. That's the fraction of how many people were in that group. And then here's the fraction for the 1/2 to 1 hour, and then here is where you're going to put the fraction for greater than 1 hour. Once we have that fraction, we can get a percentage from it. So find the decimal, then move it over 2 spots to get the percentage. And then here's the kind of weird part. We want to figure out, well, what amount of degrees do we need to actually draw on our circle chart to make that size section? So we're going to take that percentage and we're going to multiply it by 360 because there's 360 degrees in a full circle. And that's going to give us, in this first case, 213 degrees. So when you actually go to make your circle graph, you're going to get a protractor or something along those same lines, measure out 213 degrees, and then draw that as your first section. Second section, measure that out here, that's going to be 60 degrees. And then the last section, that's what I'm going to have you find. So just to kind of get a little bit of practice using this data, go ahead and pause the video, find the fractional part, find the percentage, and then find the number of degrees that section would be. So go ahead and do that and then answer these 3 questions. Okay, so we did that, we get these. So you get 121 out of 500, 24%, and then 87 degrees thereabouts. So there was a total of 500 people. The percentages should total 100. Occasionally you'll get like 99.9 because of rounding errors.
Dan Child, Kinley from the middle school is waiting for you in your room. Dan Child, Kinley from the middle school is in your room.
Sorry about that. Okay, so and then if we draw it, again, I'm not going to have you physically go out and measure it right now, but if you're going to make one for your project, you would want to go out and actually use a protractor and measure those parts to actually physically draw your circle graph like that. All right, time series graphs. So this is the kind of last one that we're going to go over. And you've seen these ones quite a bit. We will almost always have our time be our x-axis, and then we're going to have whatever we are measuring be the y-axis. So we want to make sure that we have equal spacing between all of these parts. So here it's every few months, so it's like every 3 months kind of time. And then they're going to be taking those measurements, so it's consistent. You don't want to do like, well, here's 3 days, here's a week, here's one month and they like difference, because that can really be visually misleading towards people. So what these are really good at is showing trends over time. So this is the amount of timber production in any given month. So we can see, hey, in January we have this kind of lull, and then we have a big spike in April, and then July and October kind of about the same, maybe a little bit lower, and then another drop in January. And then we see it go back up, drop, go back up, drop. So over time, it's increasing, but I always see that drop in January. So this is a really nice way for us to see trends, right? I see a trend of one, it's gradually going up, but two, I see that trend of, hey, in January that production level drops every year, which kind of makes sense because it's a little bit harder to harvest wood in the winter, right? So we typically draw these with points at the place where it is being marked, and then we draw a line from point to point to kind of show the change of what leads where. Is if I just had the dots there, it's a little bit harder to see the trend. So, but with those lines, it really helps show where things go and how they are changing from time period to time period. So overall, here's some kind of general guides for all of those types of graphs. Bar graphs are very much a universal go-to whenever you're trying to measure things like the amount of things or the percentage of things. Bar graphs work just fine. Where they can kind of have some problems is if they're very, very large numbers, but the results are very, very close together, and you have to use those little breaks. If those breaks are used incorrectly, it can be very misleading, as we kind of saw. So that's their kind of one drawback there. A pair two chart, you want to use those if you're worrying more about what the biggest things are versus what the littlest things are, kind of how they compare numerically versus just kind of in general, what were the values. A circle graph is when you're looking at more, how does it compare to the whole versus how does it compare to one another. And then a time series graph, you want to use that whenever you're trying to measure the same thing over a period of time. They really don't do anything else, but they do that one thing very, very well. That is a very strong use case. And then finally, for any graph which you ever make, you want to make sure, one, you have a title. Two, you label the axes. And three, you identify what units you are using to measure. Okay. You want to avoid trying to influence how things look. Making things pretty is fine, but if it's pretty, but that makes it more misleading, that is not worth it ever. You want to have your graphs be very easy to read and not mislead people. And then my final, my go-to way of letting you check and say, hey, is my graph good, right? In a report or a project, any graph you put in there, anybody should be able to look at that graph and its title and its labels and only those, and be able to understand without bias what is going on and what that information is telling them. So that is the go-to way to check and say, hey, is this graph complete or not? If I take away all the other context for it and just look at just that, could you give it to a complete stranger and they could look at it, read the title and the labels, and know exactly what it is trying to tell them? That is the sign of a really well-made graph. And that's what I'm going to kind of want and expect from you when we make our project for this chapter. So with that, that is our 2.2. So here is our homework. We're doing 1 and 2, and then go ahead and do 3 through 15, the odds. And I'll talk to you guys next time.